Greetings, Spartan fans. We are going to talk today about lots of asymptotes. So we've been doing all of the things, the horizontal asymptote, the end behavior, intercepts, etc. And now we're going to take it up a notch. We're going to start with something like, we do not need the parentheses. Ay, ay, ay. Here we go. X squared plus x minus 12 over x squared minus 4. Okay, so my suggestion is always to factor first, and then maybe we can reduce. And you can find the y-intercept. You can find all the y information right from the beginning, or you can wait till you factor and reduce. Personally, I think it's a lot easier just to do everything from the factored and reduced equation. So when you factor this, you get x plus 4 times x minus 3 over x plus 2 times x minus 2. And nothing reduces, therefore there is no whole. So you'll notice, though, that this particular problem now is going to have a double vertical asymptote, and it's going to have two x-intercepts. That is possible. You could only have one y-intercept, but you can have multiple x-intercepts. So let's fill in all the information. So our vertical asymptote, there are going to be two, and notation matters. X equals -2 and x equals +2. Write them separately. It's a bit better to write them separately in this case. My horizontal asymptote, divide the lead coefficients, and that's going to give you y equals 1. X squared over x squared, that's going to give us 1. All right, keep on going. Our y-intercept always make x 0. So if x is 0, we're going to get 0, 3. And lastly, our x-intercepts, and you'll notice that every time I write it, I put a little s in parentheses because there might be more than one. In this problem, we're going to have two. We're going to have one at -4, 0, and we're going to have one at 3, 0. Okay, well, we haven't graphed anything yet that has a double vertical asymptote and all these multiple x-intercepts. I encourage you, as you're going through the video, to pause and try and draw it all on your own, and then come back and see how you did. So I've got an asymptote at x equals -2. I have an asymptote at x equals +2. And I'm going to have a y-intercept at 0, 3. And then -4, 0, and 3, 0. Okay, so here's what I know. I did not plot the horizontal asymptote, and this is a problem for many people. Keep in mind that the horizontal asymptote, what's happening as x approaches infinity and what's happening as x approaches -infinity. Do not draw the horizontal asymptote in between the vertical asymptotes. You will lose points. How I have it drawn is not correct. End behavior. End behavior talks about what's happening as x is getting really large. Okay, that's really large is over here to the far right, and to the negative direction is over here to the far left. What is happening in between x equals 2 and x equals -2 does not describe the ends of the graph. No, I'm going to erase this horizontal asymptote, and it should only be at the ends of the coordinate plane. This is exactly how you should draw it. Nothing in the middle. So can I cross a horizontal asymptote? Well, yes, you can. End behavior, horizontal asymptote. As x gets really large, not in between -2 and 2. All right, so I'm going to kind of plot what I know. I start with the middle. All the information I know has been graphed already. I don't know any other points on this graph. So what's happening in the middle has its own separate end behavior. What's going on in the middle could be going up, up. It could be down, down. It could experience up, down end behavior, or it could experience down, up end behavior. So what's happening in the middle has one of these 4 options. Okay, well, let's start with down, down end behavior. If this graph were to go down, down, that means that it would require crossing the graph at the x-axis, but it can't because our only x-intercepts are at 3, 0, and negative 4, 0. So the middle cannot be going down, down. The middle can also not be going up, down. For those same reasons, it would require that the graph cross the x-axis, and that can't happen. So the graph cannot be going up, down, nor can it be going down, up. The only option for what is happening in the middle of this graph is for it to be going up, up. Now, does it have to look like I drew it? Of course not. It could look something like this. It doesn't matter as long as your graph is approaching both vertical asymptotes. Okay, the middle. I'm sorry, not the middle. The right and the left-hand side. We're going to go back to multiplicity, and we're going to go back to bouncing and crossing. So now we're putting all this polynomial stuff together with the asymptotes. Both of the x-intercepts have a multiplicity of 1. Therefore, I'm going to cross. All right, well, what on earth does this look like? If I'm going to cross over the intercept, but I have to approach the horizontal asymptote, only way that's going to happen is if it looks something like this, which can't be because the way I've drawn it requires a bounce. And you know what? It doesn't bounce. The degree is odd, which tells me it needs to cross. So everything I just drew is incorrect. I have to come up from the bottom, cross over the x-intercept, and approach the asymptote from underneath. And the same thing is going to happen on the left. And that is what my graph looks like. Now, there's a lot. Also, there's another way that we know that the branches on the right and left look as they do. If you look at the degree of the actual asymptotes, yes, asymptotes have a degree as well. And their degree is, or their multiplicity, let's call it multiplicity instead. Their multiplicity is odd. And so instead of saying that we cross over, we talk about it as going in the opposite direction. And here's what I mean by that odd opposite. Here's what I mean. The graph on the left-hand side, so to the left of -2, my graph is approaching negative infinity, which means that to the right of -2, I need to be approaching positive infinity. The left side is going down, therefore the right side has to be going up. And along those same lines, if you look at your asymptote at x equals 2, the left side of the asymptote is going up, which means the right-hand side of the asymptote needs to be going the opposite direction. All else fails, you could plug in a point and check. This is not easy stuff. Okay. We're going to do this problem very similarly. I'm going to give it to you in factored form, but I'm going to make one minor change, and it is going to drastically change this graph. Here we go. So in factored form, we had x plus 4 times x minus 3. So I'm going to leave the numerator the same. X plus 4 times x minus 3. So the problem is going to be nearly identical, but we're going to throw an exponent on, and you're going to see how this is going to drastically change the graph. And we're going to change the denominator. Instead of being x plus 2 times x minus 2, we're going to have it be x plus 2 squared times x minus 2. This is going to drastically change things. My intercepts aren't changing. My x-intercepts, I should say, aren't going to change. And my vertical asymptotes aren't going to change. but my horizontal asymptote is going to change, and this graph is going to look wildly different. No hole, because we didn't reduce anything. That's terrible. All right. So my vertical asymptotes, we're going to start writing down multiplicity. So my vertical asymptote is going to be at x equals -2. I did not leave myself very much room. I'll have to do it down here. X equals -2 with a multiplicity of 2. If it were an intercept, we would say bounce. We'll talk about what this means in just a minute. And then I still have a vertical asymptote at x equals 2. So this is going to be x equals 2 with a multiplicity of 1, which means opposite, odd. My graph is going to go opposite directions on either side of the asymptote. And when the multiplicity is 2 instead of bounce, you can call it bounce if you would like, but our graph is going to go the same direction. Oh my God, what does that mean? Patience, I will show you. The y-intercept has now changed. So I believe that when you plug in 0 for x, let's see what we get when we plug in 0 for x. You know, I'm doing this on my own. No one's around to correct my mistakes. -12 over -8. -3/2, I think. -12 over -8 divided by -12 over -8, +3/2. That should be +3/2 divided by 4. And then the x-intercepts are still going to be at -4 and 3 with a multiplicity of 1. So we're going to cross over. But now this horizontal asymptote is going to change. And you know that whenever I've been doing these problems, I've always written it the same way. I write it as horizontal asymptote / end behavior. Okay. Notice that in the numerator, if you were to multiply it out, in the numerator you would have x squared, blah, 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 who cares? In the denominator, I would have x cubed. And the reason why it's x cubed is because I have x squared times x, which is x cubed. So now x squared over x cubed, that's the same as 1 over x. As x gets really big, y approaches 0. How on earth is this going to happen that I have an asymptote on the x-axis, but yet I have 2 x-intercepts? You are in big kid math now. We are like talking about all kinds of asymptotes, bouncing and crossing, and now we're talking about, you know, multiplicity of asymptotes. We're talking about crossing asymptotes. Here we go. I have an asymptote at x equals -2. And here's what I'm going to do. I'm actually going to write down here at the bottom, I'm going to write down here that it has even multiplicity. That's going to help me when I put everything together. And then I have a vertical asymptote at +2. And it has odd multiplicity, which means it's going to go the opposite direction, odd opposite. And then I have an x-intercept at -4. I have a another x-intercept at 3. And I have a y-intercept at +3/2. Okay, but this is messed up. How on earth am I going to have a horizontal asymptote at the on the x-axis, but yet there's intercepts? Okay, it is called end behavior for a reason. 3 is like 3, 0. Okay, end behavior talks about infinity. Infinity is way over here, somewhere off my graph. You can't even see it. Negative infinity is way off my graph. You can't even see it. -4 is measurable. Infinity is not measurable. Do not draw the horizontal asymptote anywhere other than off to the far sides, and that is what that's what I should see. If you draw the asymptote here, you will lose points. All right. How on earth am I going to put this graph together? Start in the middle. That's my advice to you. We cannot cross the graph here on the x-axis. The only place that my graph crosses the x-axis is where these x-intercepts are. The only way that I can draw this middle piece so that it doesn't cross the x-axis is for it to have up end behavior. And you want to draw a parabola, you want to make it funky like this, whatever. I just want to make sure that you have a graph that approaches both asymptotes. That's what I'm going to look for. You have a curve, and it approaches the asymptotes. There you go. Okay. You can plug in points. It's going to take you forever. I do not recommend plugging in points. And I'm going to use this whole odd opposite thing. I know that the degree of x equals 2, that asymptote, the degree was odd. So to the left of the asymptote must go up. To the right of the asymptote must go down. I also need to cross at the x-intercept. So what's going to happen is I'm going to come down, like I'm going to cross over, and I'm going to come up over the axis, and I'm going to come over, and eventually I'm going to come back down and approach the asymptote from above. I shouldn't have drawn this quite so high up. I'm going to just erase this a little bit and draw it a little bit better. What I need to see is clearly that you have crossed over the x-intercept and that you are approaching the asymptote from above. So what I mean when I say from above is that this graph is coming over and it's coming back above the asymptote at y equals 0. And the exact opposite is going to happen on the other side. At x equals -2, I have even multiplicity, which means that what is happening to the right of the asymptote, the graph is going up. That means that to the left of the asymptote, my graph also has to be going up. But the degree of -4, I'm going to cross. So what's going to happen is I'm going to cross over my intercept. I'm going to approach, and then I'm going to go down below and come back up. And here's what that looks like. How far down below should I go? Like this part, I don't care. Just make sure you go down. Maybe it goes all the way down and comes back up. I don't know, but here's what I'm looking for. Did you cross your x-intercept? Then did you approach the asymptote from underneath? This is a graph that would get you full credit. So here's what we know. I'm crossing the intercepts because they both have odd multiplicity and odd crosses. I know that based on the degree of my asymptotes, so the multiplicity at x plus 2 was 2. So you'll notice that at -2, both sides of the asymptote are going up, and at +2, they're going in opposite direction. To the left of the asymptote is going up, and to the right of the asymptote is going down. Do not cross over. Do not draw the horizontal asymptotes in between. There is no asymptote because what's happening between -2 and 2 is measurable. Infinity is not measurable. -4 is measurable. 3 is measurable. Infinity is way to the left and way to the right.